How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, as we move forward into our best path selection process, as we go through each one of the options, I am going to spin up BGP peerings for all of our devices. So even though we won't technically be going through and doing anything routing wise, we're not going to be doing NAT. The goal is to test out all the different capabilities. So my goal right now with you guys is I'm going to take this iNet server, which is basically just going to propagate Google, so Quad 8 for us, and I'm going to get that peered to both of these routers here via BGP. And then once that's done, we're going to go ahead and all the connections, R34, 58, 59, anything that connects to the internet. So 58, 59 on both these peerings, 24, 23. So anything that that's already up and running, we're going to go ahead and just get BGP peering stood up to all those routers. It should take us a few minutes. I want you guys to see all of these steps as I'm going through them, instead of me just going, hey guys, I set all these connections up, because I'm assuming that some of you want to follow along and all that good stuff that goes along with it. So that's what we're going to go do. So the intention here would be that down the road is, if we're attached to say PC68 or on PC72 or something like that, if we do a trace route to Google, right, I want to be able to manipulate a BGP best path algorithm option, local preference, med, compare router ID, whatever it might be. I want to be able to, depending on which path we take from R33 and R34, I want to be able to affect the direction we go and how we would do that. So that's what I'm going to go ahead and do. So I'm going to get out of the way. This is going to be it's going to be quick. I'm not going to be spending a lot of time explaining anything. I'm just going to be, doing the configuration so that you guys can see the syntax and follow along at home if you are looking to do that. So the first one we're going to go ahead and do is we're going to go on the internet server here, pull him up. And if you're wondering why I have two of them, the answer is very simple, really. It's because I'm eventually going to have both of these guys advertising Quad 8, so we can take a look at how any cast works from an internet perspective, so you guys can see the different paths you can take depending on where you are in the internet. So on the iNet server, since we have 62 and 44 already spun up, I'm going to go ahead and configure this guy real quick. Hostname is going to be inet-srv1, and the interface loopback 0 will be Quad 8 with a /32 mask. Wish I could do /32, but I can't. And then we're going to go ahead and, I don't think I've configured this guy yet, and I have interface gig 0/0, IP address here will be 3.1.62.1, excuse me, /24, no shut that, and then we're going to do gig 1, and then we'll go 3.1.44, no shut that, and then we are going to, he peers to both. So I want to do, I'll just do eBGP. I'll create AS1 for this guy. So it'll be router BGP 1. Actually, no, I can't do that. We'll do 101. And then that'll be an additional AS you might see. So we're going to go ahead and we'll go no BGP default IPv4, and then neighbor 3.1.62.62, remote AS is going to be 3, and we'll do 44.44, remote AS is 44, remote AS is 3, and then address family IPv4, we'll go ahead and activate that one as well, and then we'll do network of 8.8.8.8, mask will be /32. And we're going to say do right on that. So I'll go to 62, Then we'll do show run section BGP. So in this case here, we're going to have to go router BGP 6245, and then do show IP interface brief. Okay, so neighbor of 3.1.62.1, remote AS of 101, address family IPv4, and we're going to go ahead and activate that. And then I'll do the same thing on, go ahead and save that config while I'm there. I did save it there. So XR44, I'll do the same thing here. So 62, I formed a BGP peering, do show IP BGP, and we now have quad 8 in the routing table. And 101 is my source AS. So now if I go to 44 and do the exact same thing, log it as Rob and Cisco. You can name, your username could be anything. So router BGP 4463, we're going to do show IP interface brief 3.144, so neighbor 3.1.44.44.1, remote AS of 101, address family IPv4 unicast, and we're going to do a route policy eBGP peer in and out. We're going to do route dash policy eBGP peer, and we're going to say just pass. We're going to go ahead and commit that config. Momentarily, we should have a BGP peering up and running, and we'll be good to go there. So do show IP BGP sum. There goes the peering. We've learned one prefix. We've got quad 8 in place. So there we go. That's that. Now I'm going to focus on the left side of the topology and get all these guys peered up. So this will take a few minutes. So on R33, since we already have one peering on R33, notice this is installing route here, which is good. Do a show IP BGP. We have quad 8 coming through, which is good. So now what I'm going to do is show IP interface brief. We've got 3.33.62.33 configured on gig 0/2. I'm going to do router BGP 65001, and I'm going to do a neighbor to 3.33.62.62 remote AS of 3, and then address family IPv4. We're going to go ahead and activate. And then now that that's done, we're going to go back to 62 and do the same thing here. So we'll do neighbor of 3.33.62.33, remote AS of 65001, address family IPv4, and then activate. And there's a question, how am I doing deleting the remote AS 65001? I am using the control W command. So if let's say I do this, something like that. If I do control A, I go to the beginning of the line. If I do control E, I go to the end of the line. If I press control W, I erase that word. And if I press control U, I erase that line. So those are just some of the keyboard shortcut commands that you can use in iOS. So definitely useful CCIE pro tip. So now we've got that done, and I've saved the config. We're good to go there. So as far as I'm concerned, I have BGP peering stood up to everybody. So do show IP BGP summary. So I have I should have 6 peerings. 1, 2, 3, 4, 5, 6, and I'm learning prefixes from all 3 of them. Or I should say all 6. So I'm good to go there. And I saved my config, so we should be good there. Now I'm going to go to router 34. 34 here. Show IP interface brief 134.42. Why is that? Oh, I see what the problem is. Okay. So I'm going to go to here, do show run section BGP. BGP is not currently running. So we're going to do router BGP 65001, no BGP default IPv4. I want to type a neighbor of 1.34.42.42, remote AS of 1. Address family IPv4. We're going to go ahead and activate that. And I'm going to save my config. So So one of the things I'm going to do is, for all these peerings that I'm doing, I'm just going to do provider aggregation because we've seen both of them. So I'm going to go to 42, log in, and show IP interface brief. Make sure I've got that configuration done. 134.42.42 on gig 3. I'm going to go to do show run section or begin RPL route. I have a BGP peering or route policy already there, so I'm good to go. So I'm going to type in router BGP1 neighbor of 1.34.42.34 remote AS of 65001 address family IPv4 unicast, and then route policy eBGP in and out, commit that config. And then we're going to exit out of here and then do an address family IPv4 unicast. And then we'll do a network of 1.34.42.0/24. Commit that as well. Nice thing about XR, once you commit it, saves the config. Okay, so now that I have that done, the next one is going to be 58 on 62. So we're going to go to 58, show run section BGP. There's a little bit of BGP config here, and that's for the BGP peering to the ISP. Now, we are going to talk about commingling connectivity. For right now, we don't care, right? We haven't gotten into any advanced tuning or anything like that, or messing with path selection on, determining one path over the other. We haven't done any of that stuff yet. So as far as I'm concerned, we are like CCNA to CCNP level BGP. We're starting to get outside of the basics of BGP and into some of the more advanced capabilities. When we start getting into hardcore CCNP, we will definitely dig into, how, from a design perspective, how you would do like a BGP peering for internet routing and then a BGP peering for MPLS VPN connectivity. So we'll talk about those later. Normally, you wouldn't have them sitting in the same routing table because that takes a lot of route control. So, which can get complicated quickly if you're not careful. So we'll talk about that at a later point in time. So what I'm going to do is I'm going to type in here do show IP interface brief. I'm going to do a router BGP 65001, and I'm going to type in neighbor, and this is going to be neighbor 3.58.62. Remote AS of 3, and then I'm going to type in address family IPv4, and I'm going to go ahead and activate it. Now I already have one peering stood up to 64, and the reason why I'm telling you the issues we're going to have with 62 is because we're eventually going to run into problems, and the problem that we're going to run into is actually very simple. 58 and 64 already have an BGP peering for internal routing. That's why you would use MPLS. Well, what's going to end up happening is when I go to do a peering to both the internet and MPLS via BGP, we're going to get route propagation everywhere. So we're going to run into problems. And the goal would be to mitigate them wherever we can. So I will be working with you guys on how to allow those specific prefixes and how to control that type of stuff. But for right now, it's going to get interesting before we get... We have to stabilize the network after we get everything up and running. So, and that's one of those things where having labs like this is definitely going to help you understand how that process works. So I'm going to go ahead and save this config. So there was a comment. I'm a little confused what you mean by that. So simple answer is this. 58 already has a BGP peering out to MPLS. 58 will have a BGP peering out to 62. So we're in the global routing table doing BGP for both internal and external routing. What's going to happen is we are going to have external routes and internal routes in the BGP table, and since we are doing redistribution of BGP to OSPF, we are going to have kind of a crap show going on for a little while where routes out here are going to be internal. Internal routes here are going to be external. So you're going to have 10 nets, 172 nets, 192 net, 192, 168 nets out on the internet. I'm going to show you how to control all that. So it's going to be, I do not expect this to go super smooth the entire time. We're going to hit a bunch of issues, and I'm going to walk you guys through how to fix them. So intentionally causing problems is part of the deal here, and we're going to walk through how to fix them. They're not going to be difficult per se, but you need to understand how that's going to come into play. So especially with 58, because he's got MPLS, we're going to see a lot of commingling of routes, and it'll be up to us to know how to fix that type of stuff. So that's what I mean by that. So let's go over to 62. On 62, we're going to do a peering to 3.58, so we're going to do neighbor of 3.58.62.58, remote AS of 65001, address family IPv4, and we're going to go ahead and activate that. And I'm going to go ahead and save that config while we're at it. So then that peering will come up, and you'll see what I mean here in just a minute once the peering comes online. So now if I do show IPBGP, we're going to have a whole bunch of routes. Like I said, we're going to have 10net, 192, 172, 192, all that good stuff. We have all these prefixes now in the internet router. And if I go over to 58 and do show IPBGP, we're going to have a whole bunch of routes there as well. Now if I go to router 25 as well, and I do a show IP route, we're going to have all these additional routes in here that we don't need, right? We're going to have 23, 45, 61. We're going to have, 221. We're going to have a bunch of routes in our routing table that we don't want or need. This is what I'm talking about with having to deal with route control. You would never do this in production, ever, 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 ever. So we're going to stand it up so you guys can see what it looks like to do this type of stuff. Now if I go over to, say, router 22, and I do a show IP route here, we're going to get the same thing. We're going to get a bunch of routes over BGP, and so we see all that type of stuff coming through. We're going to see some new stuff. So it's going to make, so like for example, we should never see an internal route via BGP. We should never see this. This is RFC 1918. We should never see this coming in over internet routes. So this is what I mean about having to advertise everywhere. Right now, there is no reachability. Well, there's probably still going to be reachability, but it's going to be a crap show. So again, we'll fix that. So that's part of the whole purpose here of going to this lab is to, okay, now that we have all these things going on, how do we control them? This is where, to me, where you jump out of the safety of a lab, jump out of the safety of a lab and put yourself in the middle of a, holy crap, I just broke the network. That's how you handle these things. So with that being said, let's go ahead and continue moving forward. So on R59, we're going to go to do the same thing. We're going to do show run section BGP. Go. A router BGP 65001. We'll type in here neighbor of 3.44.59.44 remote AS of 3. And then address family IPv4. We're going to go ahead and activate that. And that'll make things a little bit simpler to work with. I'm going to save that config. I'm going to go to 44. We're just going to double check the IP addressing. Okay, it's there. Router BGP, in this case here it's 4463. Neighbor 3.44.59.59. Remote AS of 65001. Address family IPv4 unicast. And then route policy eBGP peer in and out. Commit. So that'll come up here momentarily, and then we'll move ourselves over here to this side here. We'll do the same thing. I think 22 is already squared away. 22 should be good. Yep, 22 is good. So the next one would be, let's actually go back this way here. 22 is good. Now we just need to do 21. Show run section BGP. And we're going to do router BGP. What did I use on 21? 22 is show IP BGP. I am show IP BGP summary. My local AS is 65003. So 21 65003. No BGP, default IPv4. And then we're going to do neighbor of 2.21.61.61 remote AS of 2. We're going to go ahead and activate that. And we're in good shape there. That'll come up momentarily. I'm going to save that config. We will, let me bring this down just a little bit so you guys can see we're on 61 now. 61. Go to global config, router BGP, do show IP interface brief, 221.61.61. So router BGP2, neighbor of 2.21.61.21, remote AS of 65003, address family IPv4, and then activate. Save that config as well. So that's basically how that's going to come into play. So that peering is up now as well. So 21 should have basically the same design as well. Cool, we're getting all the routes in, everything looks pretty good. Now, obviously I wouldn't be doing this if this was production, because right now there'd be a whole lot of stuff not working. I probably wouldn't even be able to get on VPN or connect to anything. It would be very, very slow, and I'd be like, crap. But in this case here, I'm not. And this is where you get into some of these designs where I've got multiple AS hops, 37, 10, 65001, 2, 3. So I'm getting some very in-depth routes now. So it's getting interesting. But that's what makes this is what I'm looking for, this lab to do. All right, so I'm going to come down here to scoot this down just a touch. So 24 should already be peered. Okay, then it's 23. That's okay though. 23, I don't think I've done this one yet. 23, show IP BGP. Okay, BGP not active. Okay. So, do I go that far? Yeah, we might just double check the config. So show IP BGP, and we know that peering is good. So, do I want to do this one as well? I think where we're at is good. I think having this amount of peerings, the smaller site, I think we'll just do, I think we're good there. I think having 1, 2, 3, 4, 5, 6, 7 peerings, I think that's sufficient. I think that'll get the job done. I don't think we need to have all these guys stood up as well. So I'm not going to go any further than what we already have working, because, well, it's we're already 20 minutes in, and I don't want to sit there and like try to explain and do an hour-long video why we have to do what we have to do. So what I'm going to do in the next video is you and I are going to look at what's being propagated, and we're going to basically stop that from happening. So basically what we want to do is do what internet service providers do and put in preventions to receive routes that we don't want. I want to show you exactly what that looks like. So if you guys have any questions, comments, concerns, feedback, let me know in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you guys in the next video.